Now the third property is color. See, when we talk about the color of any object just depends upon the wavelength of light that it scatters. Suppose if we see that, we have seen that suppose this is a mountain and I say mountain appears to be grey. You know why it appears to be grey? What happens when the light falls on it, it absorbs all colors but reflect the few colors. So in this case, what happens when the light falls on it, absorbs maximum of the color, but the color which it reflects appears to be is grey actually. That is why it appears grey. So that means the light the wavelength which is just reflected by an object is the color of that object. So likewise, when we see in the colloidal solution what happened, suppose this is my colloidal solution in which I have milk and water. So when light light falls on it, it absorbs certain light and just scatter the other some wavelength of light, and what happens due to scattering of that wavelength, the color of the object of the colloidal solution is like that. Like for example, when light falls on it, what happens? It scattered red color. That is why it appears to be red. But and also one more thing, you know that the color of, like for example, if I say that colloidal solution of milk and water appears to be red, it is not red from all sides. Actually the color of the colloidal solution changes according to the direction of the viewer and also at which angle we are going to view it. Suppose if we view it from this side, it appears to be red, but if we view from this side, it appears to be blue. So that means the color of the colloidal solution depends upon the direction of the viewer and also at the angle at which it is viewed actually. And you know that the reason behind the color of the colloidal solution is same, that you can say it scatter a particular wavelength of light, and the light that it scatter impart the color to that given colloidal solution. Likewise, for example, we have a gold soul. You know that in gold soul we get to see many colors, like when the particles are small, it appears to be red. When the particles is comparatively bigger, the color changes to purple. When the particles become more bigger, it changes to golden. So likewise, due to the change of the particle size, because according to the size of the particles, the scattering of light is going to take place, right? That means a smaller size will scatter some other wavelength of light, the bigger one will scatter some other wavelength of light. So likewise, we get to have different wavelength of light scattered, and likewise the color of the colloidal solution changes. So this is what is color. So that means colloidal solutions are colored because they scatter a particular wavelength of light. Now the next property is Brownian movement. It's an important movement and it is mostly shown only by the colloidal particles. So what is it exactly? I'm just going to tell you first. See, suppose this is my colloidal particle. So what happens when I see it with the powerful instrument, what I get to see that these particles, suppose I have make one particle, I get to see that its motion is like that, this here to here, here, then here, here. So we can say that this kind of motion of the particle, that is a motion in a zigzag manner, is seen in case of colloidal particles. This is something called as Brownian movement. Now what is the reason that they show this kind of zigzag movement? Actually what happened, they have a moderate size. Their size lie between 1 nanometer to 1000 nanometer. So that means their size is moderate, so they don't settle down. They are actually stable. But what happened, there are collisions between the dispersed phase and the dispersion medium. There is the collision between the dispersed phase and the dispersion medium, as the particle do not settle, so they are constantly moving, and when they are moving, suppose this is my particle, this is one particle, this is my one particle. So this particle when come, it strike this, it gets shifted to here, it gets shifted to here. So likewise they are just undergoing different collisions, they are hitting just each other, and the line at which they are moving appears to be zigzag, and that is something called as Brownian movement. And you know, this is the reason that they are very stable, like they show this kind of movement, they are very stable. That is why when we keep them, the particles do not settle at bottom. The second reason is that because their size is a moderate one. Neither you can say neither too small, neither too big, they are of moderate range, that is between 1 nanometer to 1000 nanometer. So this is our property color and the Brownian movement. Now we are going to start with another property, that is the electrophoresis.